Imagine a spacecraft that looks like a miniature space shuttle, but with a twist. It's smaller, sleeker, and designed for a new era of space exploration. Unlike the iconic shuttles that carried astronauts into orbit, this vehicle is built for a different purpose, one that doesn't require a human crew on board. Notice there are no windows, no seats, and no astronauts inside. The cockpit is empty, emphasizing its unmanned nature. Every inch of this craft is optimized for autonomy and resilience, allowing it to withstand the harshest conditions of space without risking human life. The X-37B launches vertically atop a powerful Atlas V rocket, just like a traditional spacecraft. Once in orbit, it can remain circling the Earth for months or even years at a time, conducting its secretive missions. When its work is done, it re-enters the atmosphere and lands smoothly on a runway, guided entirely by advanced onboard computers. This entire process, from launch to landing, is performed without a single person on board. This remarkable vehicle is known as the X-37B. Operated by the U.S. Space Force, it is one of the most secretive and advanced assets in America's space arsenal. Its missions are shrouded in mystery, fueling speculation and curiosity around the world. The primary mission of the X-37B is to test and validate new technologies in the unforgiving environment of space. It serves as a platform for experiments that could shape the future of spaceflight, from advanced materials to next-generation sensors and communication systems. Sometimes, it even deploys small satellites, expanding America's capabilities in orbit. Think of the X-37B as a high-tech workshop orbiting above our planet. Inside its payload bay, it carries cutting-edge scientific instruments and experimental hardware. Robotic arms and specialized equipment allow it to test new devices in the vacuum of space, where only the toughest technologies survive. The experiments conducted aboard the X-37B help the United States develop smarter, more resilient spacecraft. Each mission provides valuable data, ensuring that America remains a leader in the increasingly competitive and crowded domain of outer space. While many details about the X-37B's activities remain classified, its very existence signals a new era in both defense and scientific discovery. The program represents the cutting edge of what's possible when innovation and national security come together in the pursuit of knowledge. The X-37B is part of a broader shift toward reusable, intelligent spacecraft. Its ability to perform complex tasks autonomously, return to Earth, and be prepared for another mission sets a new standard for efficiency and sustainability in space operations. As the X-37B embarks on each new mission, it carries with it the hopes and ambitions of a nation striving for excellence in science, technology, and security. Every launch is a step forward in America's quest to explore, protect, and understand the final frontier. Quietly orbiting high above, the X-37B is more than just a machine. It is a silent guardian, a pioneer of tomorrow's technology, and a powerful symbol of human ambition to reach beyond our world and touch the stars. The mission began on a warm, humid Florida evening at the legendary Kennedy Space Center, a place where history has been made time and time again. As the sun dipped below the horizon, painting the sky in shades of orange and purple, the air buzzed with anticipation. Engineers, scientists, and military officials gathered, each aware that tonight's launch was unlike any other, a mission shrouded in secrecy, with objectives known only to a select few. Standing tall and silent on the launch pad was a SpaceX Falcon 9 rocket, its sleek frame illuminated by floodlights. Hidden within its payload fairing was the mysterious X-37B spaceplane, a cutting-edge vehicle designed for long-duration missions in orbit. The rocket, a marvel of modern engineering, was poised to carry its secretive cargo into the unknown. Inside mission control, the atmosphere was electric. The countdown clock glowed brightly, each second bringing the team closer to launch. Operators monitored their screens intently, communicating in hushed tones, their faces a mix of focus and excitement. Every system was checked and double-checked, ensuring nothing was left to chance. Suddenly, the silence was shattered by the deafening roar of the Falcon 9's engines. Flames erupted beneath the rocket, casting dramatic shadows across the launch pad. With a surge of power, the vehicle lifted off, climbing steadily into the night sky, leaving a trail of fire and smoke in its wake. Spectators watched in awe as the rocket soared higher, its bright plume visible for miles. The launch was a breathtaking display of power, precision, and human ingenuity, marking the beginning of a mission cloaked in mystery. For those watching, it was a reminder of the incredible feats possible when technology and determination unite. As the Falcon 9 continued its journey, the first stage separated and began its controlled descent back to Earth, landing flawlessly on a drone ship stationed in the Atlantic Ocean. Meanwhile, the second stage ignited, propelling the X-37B further into orbit, demonstrating the remarkable reusability and reliability of modern rocketry. Reaching the designated altitude, the payload fairing opened, and the X-37B was gently released into the vastness of space. The Spaceplane's mission had officially begun, its objectives hidden from public view, but its presence a clear signal of technological prowess. Back in mission control, cheers erupted. As confirmation of a successful launch came through, the team celebrated not just a flawless liftoff, but the demonstration of reliable, repeatable access to space, an achievement that showcased America's advanced aerospace capabilities. As the X-37B orbited silently above the Earth, it became a symbol of dependable space operations, ready to respond to emerging challenges or opportunities at a moment's notice. Its journey was a testament to years of innovation and collaboration. The Falcon 9's spectacular ascent was just the opening act for a mission that would unfold far above, out of sight but never out of mind. A silent sentinel, carrying the hopes and ambitions of a nation into the final frontier. Just minutes after liftoff, something remarkable happens with the Falcon 9 rocket. Its first stage, having completed its initial job of propelling the spacecraft toward orbit, doesn't simply fall away and disappear. Instead, it performs a carefully choreographed maneuver, turning itself around in the thin upper atmosphere and beginning its journey back to Earth. This is a moment that captures the imagination of engineers and space enthusiasts alike. In the early days of spaceflight, rocket stages like this were considered expendable. After their fuel was spent, they would tumble back to Earth, crashing into the ocean or burning up in the atmosphere, never to be used again. Billions of dollars worth of hardware was lost with every launch, making space travel incredibly expensive and limiting how often missions could take place. But SpaceX changed the game entirely. Now, instead of being discarded, the Falcon 9's booster uses its engines and grid fins to guide itself back through the sky, landing upright on a precise landing pad at Cape Canaveral. Watching the booster touch down gently on its landing legs is like witnessing science fiction become reality. This incredible feat of engineering is known as reusability. It's a revolutionary concept that has transformed the economics of spaceflight. Engineers and mission controllers celebrate each successful landing, knowing that every recovered booster is a step toward a more sustainable future in space. By refurbishing and reusing these rockets, SpaceX dramatically lowers the cost of reaching orbit. This means more frequent launches, more opportunities for scientific research, and a faster pace of innovation. The ability to fly the same rocket multiple times is a game changer for the entire industry. The US military is one of the many beneficiaries of this breakthrough. Launching satellites like the X-37B spaceplane has become more affordable and reliable, allowing for greater flexibility and security in space operations. The cost savings and increased launch cadence are invaluable for national defense and technological advancement. This powerful partnership between government agencies and private companies like SpaceX is driving progress at an unprecedented rate. By combining commercial innovation with national goals, the United States is pushing the boundaries of what's possible in space exploration. Each time a Falcon 9 booster lands, it's more than just a technical achievement, it's a symbol of a new, sustainable era in space. The sight of a rocket returning safely to Earth, ready to fly again, inspires hope for a future where space is accessible to all. Reusability opens the door to ambitious missions that once seemed impossible. Imagine building bases on the moon, sending humans to Mars, or launching massive constellations of satellites, all made feasible by rockets that can fly again and again. The return of the Falcon 9 booster is more than just a technical milestone. It's a smarter, more efficient way to explore the final frontier, bringing humanity closer to the stars with every successful landing. The X-37B is a flying laboratory, testing new technologies in space. For its 8th mission, it carries upgraded batteries, solar cells, and thermal protection. A key experiment involves laser communications, sending data with light beams. This could revolutionize satellite communication, making it faster and more secure. The mission tests materials for deep space exploration, learning from years in orbit. The X-37B allows real-world experimentation, crucial for future space technology. The data collected ensures America's space assets remain advanced and reliable. How do spacecraft navigate in space? Typically they use GPS, but if GPS signals are jammed, a spacecraft could become lost. The X-37B tests a quantum inertial sensor, a first in space. This sensor uses quantum physics to detect motion, providing precise navigation. It offers a backup to GPS, making spacecraft more resilient and autonomous. This technology ensures satellites operate securely, even if GPS is compromised. It's a quantum leap, paving the way for independent space navigation. In military operations, secure communication is crucial. As reliance on satellites grows, protecting communication links is vital. The X-37B tests laser communications, offering secure, high-speed data transfer. Laser beams are narrow and focused, making interception nearly impossible. This mission explores military-commercial satellite network integration. A resilient communication web ensures data gets through, no matter what. Secure space communication is key to national security in the 21st century. The X-37B's experiments build a shield to protect America's space assets. Advanced communication technologies ensure vital information is transmitted safely. The X-37B program is shrouded in secrecy. While some technologies are shared, the full mission details remain classified. This secrecy protects national security information from adversaries. The mission's duration is unknown, but it's expected to be long. The X-37B's versatility makes it a subject of global interest. Secrecy ensures its capabilities remain a strategic asset. The program demonstrates a commitment to innovation and staying ahead in space. The X-37B mission symbolizes a new era in space. Space is now a critical domain for national security. The mission tests technologies for resilient autonomous space assets. The U.S. military's partnership with companies like SpaceX is transformative. This collaboration accelerates development, benefiting national security and commerce. The X-37B's work has implications beyond military use, aiding scientific exploration. It tests tools essential for future missions to Mars and beyond. The mission represents a forward-thinking approach to space exploration. Investing in advanced platforms shapes the future of space technology. The X-37B program reinforces America's leadership in space. The X-37B charts a course for America's future in space. Its mission embodies innovation, resilience, and peaceful cosmic presence. Each data point informs the design of future spacecraft. Reusability, demonstrated by SpaceX, makes space more accessible. Government-private partnerships drive unprecedented progress. Security remains crucial as space becomes more contested. The X-37B's technologies will be standard on future satellites. The mission is a testament to human exploration and ambition.